This example is going to look at how we can use arrays with functions. So let's take a look at main. And main declares two two-dimensional arrays. The first one is product information. And we've got 5 products, and we're storing information in 2 rows. The first row is a stock keeping unit or product identifier, and the second row is zeros and ones indicating whether the item is at regular price or whether it's on sale. So 1 means it's on sale and 0 simply means it's at regular price. Down below that, I've got a second 2D array. This one is doubles, and the first row is the regular price of every item, and the second row is the sale price. The items are lined up with the SKUs up at top, so 23 is at $23.99, 84 is at $24.49, 93 is at $57.89, and so on. So we're treating this as parallel arrays, but they're actually two-dimensional arrays. So what we're going to do in our program is we're going to ask them to enter an SKU for the item they would like to purchase. They're going to do that until they put in a 0. Then what we're going to do is we're going to get the price for that item. And get price is going to look it up in the appropriate tables, and it's going to return the total price. Now that's a function we've written ourselves, and we're going to look at it in a moment. If the price is 0, that means it didn't find it. The SKU was not in our list, and so we say product not found. Otherwise, what I'm going to do, I'm going to add it on my total price. I've got an array of SKUs which have been purchased, and I'm going to insert the SKU into that array. And after that, I'm going to put in the purchase price I found into another array of prices. The loop will continue until it gets an SKU of 0, at which point it will print out a list of all the items purchased. It starts out by printing out a header. Then it goes and loops. N purchased represents the number of items we purchased. It starts out at 0. Every time I add a new member to my list, I increment it by 1. So it's always got a count of a number of items purchased. Then I print out the SKU of the item purchased and the purchase price. Notice how I've lined the columns up. And then down at the bottom, I print out the total and the total price. So let's just run it so you can get an idea what it does. So I'm going to purchase item 23. And I'm going to purchase 57. And then I'll just say stop. And there it has it. It's 23 is $23.99, 57 is 40 for a total of $63.99. Let's go check our prices. And if you take a look up here, you notice that 57 has got a 1 beside it because it's on sale, and it picked up the price of it was 40, which is the sale price, not $47.99. Whereas SKU is not, the SKU 23 is not on sale, so it picked up a $23.99 rather than the sale price of $20. So it seems to be working correctly. Now let's take a look at the functions. When I called these functions, I passed the product info table and the price table, which are two-dimensional arrays. Let's see what it looks like when we receive two-dimensional arrays. So I've got 3 parameters for this. Get price for, the SKU, followed by the product table, and I declared it to have that number of rows and that number of columns. I can actually leave the number of rows out if I want, but the number of columns must be there due to the way it's stored internally. Since I know the exact size of these, I can just put in both numbers. Same thing for the price table. Now within there, I'm going to try and find the price of a particular item. So what I have to do is I have to look up the SKU in the product table and find what position it's in, because everything else is going to be based on the position I find it in. So now I get rather tricky. I've got a separate function called find position, and I give it product table sub 0, which is only a single subscript. So I pass that over, and I have to tell it how many are in that array, because it's a general purpose function. It may search larger arrays. I give it the SKU I'm searching for, and it's going to return the valid position if it finds it, or it's going to return a negative number, -1, if it doesn't find it. Now when it returns, if a position is greater than or equal to 0, I can actually figure out what the price is, because I know it's got a valid position. If it's 0, or if it's less than 0, I simply return the result, which is initialized to 0 up there, and it's got a 0 price, which means that the item didn't exist. We didn't find it. We are not selling any items for 0. I guarantee it. Now the next thing we have to do, if it's a valid SKU, we have to look up the product and find out if it's on sale or not. So product table row 1, in the position of that is going to be a 0 or 1, which tells us whether it's on sale or not. So my result is price table sub on sale sub position. Now on sale, if it's on sale has got the value 1, which is the second row in the table that has the sale price. But if it's not on sale, it's got the first row, row 0, and it gets the regular price. So we don't have to do any tricky things here, because it turns out that we can use this Boolean 0 or 1 to indicate whether we want to look at row 0 or row 1 in the table, because I set up the table to have that correct order, and now we can take advantage of it. So that gives me my price, and I can return it. Now, to look at find position, this is a standard linear search. It takes an array, a one-dimensional array, but one of the things we discussed about 2D arrays before, if you pass them with only a single subscript, they pass that entire row, which is exactly what we want in this case. So when I come up here, it receives the row that has the SKUs, and it treats it like a 1D array. So I can go through here, and I search for I equals 0, I is less than size, and my position has to be less than 1 minus 1, or less than 0, where I started, and I do an I++. If I find it, in other words, AR sub I, that member of the array, is equal to value, which is the value I'm searching for, it sets position equal to I. As soon as it sets position equal to I, then it's not going to be negative anymore, because this started out at 0, so it's got to be at least 0. And the next time it goes around, position less than 0 is going to fail, and it's going to kick out of a loop. So I'm actually using this position variable as a flag as well to indicate when I should exit the loop. Now, there is another neat thing we can do with functions and arrays, and that is we can do a price increase. And what I can do is write a function to increase the price of a certain item by a certain amount. And what I'm going to do is I'm going to say, we'll give it the SKU of the item. and we're going to give it the increase as a fraction. So it'll be like 1.1 to get a 10% increase or something like that. So it also needs the tables. It needs, and I'm just going to copy them because I have them up here. It needs both the price table and the SKU table. So let's copy those two parameters. Okay, so now I have 4 parameters, and I'm going to do what I did before. I'm going to say I need the position. In fact, I can just copy that entire line. This is where programming with functions comes in really useful, because now I need to do the same thing again. I just make the call to the same function I've already used. Now, if position is greater than or equal to 0, I know that it's a valid position. If it's not a valid position, I'm not going to do anything. And now what I have to do is I have to increment its price. So what I'm going to say is that now 0 and position is the regular price of the item, and I'm going to say it's star equals whatever the increase is. And then I'm going to do exactly the same thing for the sale price, because if the regular price goes up, the sale price should go up too. Oops, that's not what I wanted to do. Control C that. And now, so I'm going to do exactly the same thing to the sale price, and that's it. Now, this is different than we've seen with parameter passing before, because what we're going to do is we're going to modify a value inside an array, and we're going to have that passed back. Okay. That is different, and you can only do this with arrays. If you modify a value inside an array, it gets passed back. None of our other variables that we've seen so far have been able to modify the value inside a variable and have it passed back. But arrays are special in this way. So what I'm going to do is before we start our program, I'm going to say we have a price increase. Not a price, it's price. And I'm going to say that, let's say item 20, well, let's just say item 84. 84 goes up by 1.1, which is 110%, or it'll go up by 10%. And then I have to give it the product info table. And then I have to do the price table. And it needs these because it's going to look the product SKU up in the product info table, and it's going to modify the price directly in the price table. Once I do that, you're going to see that we get slightly different prices. So item 84 is the one. So let's just, and it's on sale. Let's just, its sale price is 21, but I'm betting that's going to go up by $2.10. Let's run it by item 23 and 84. I want to buy 23 and I want to buy 84, and that's it. Now it says the price is $23.10 for item 84 because its sale price was 21, but 10% is $2.10, so that becomes $23.10. And we did get our price increase. And it actually got modified directly in this table. So that's a major capability that arrays have when used with functions. You can modify a value inside an array and pass it back. So this little program shows a lot about how you can combine functions with arrays to vastly simplify the amount of code in your main. We've actually written a significant amount of code here, but we've been able to reuse the functions so that the main itself remains relatively short and relatively easy to read. So that's a lot of the power and the techniques of using functions with arrays.